about it, right? A lot of how we have come up in this field, a lot of the terminology and jargon that we hear all the time is just so effectively summarized in this kind of a cartoon. So on that note, all right, what's happening in my slide share? Okay, so we'll talk about what we've been doing at Schneider around implementing data science. What have we learned along the way? And I'd like this to be an interactive session. So let's ask the questions as we go. Please interrupt me if you want to say something or ask something.
We'll keep an eye on the chat too for you in case questions appear there, and we'll be looking for, there's a raise hand feature, I think. So if we see any raising hands or type into the chat, we'll let you know.
Okay, great. Thanks, Paul. All right. So just a quick introduction about Schneider. For those of you who aren't familiar, Schneider is a large transportation and logistics provider, and we provide, I would say, almost full service. We provide multimodal land transportation as well as managed transportation and brokerage. Now, many of you would have seen it used to be yellow trucks and orange trucks and trailers. Now it's orange trailers. You would have seen them on the road a lot in the Midwest. Schneider trucks are all over the place, but also a very strong presence in the rest of the country. So like I was saying, we provide a full stack of services ranging from truckload to intermodal to logistics. We have a large brokerage division as well as a large managed transportation, which we call supply chain management. In the truckload area, we service a wide variety of customers as well as have various types of service that we provide. Some of them are listed here. Similarly with intermodal, which is actually a fairly large portion of our business. On the bottom of the slide are just some stats. Obviously, the numbers keep changing a little bit year over year, but just gives you a sense of scale. Like I was saying, we are one of the largest transportation companies in North America, and it's just shown by the numbers that you see at the bottom. Geographically, we are present in US, Canada, and Mexico, and we have a small operation in China. All right, so before I show you another dense slide, let me preface this. So in the next slide, I want to show you a very quick summary of how data and analytics has grown in Schneider over the years. What were some of the landmarks? Some of the terms you'll see would be familiar to some of the folks. Some of you would have played a very important role in that part of the journey, and for some of you, it may be some new things that you'll see here. So this very dense slide gives you a timeline of how data and analytics, how technology has really shaped the company. So we have a long and rich history of decision engineering. Everything started about 85 years back when the company was founded. It started off as a small trucking business and had and grew its presence in Wisconsin and the surrounding areas. Transportation, very early on, it was realized by the founders that transportation is a very competitive business, and the margins are very competitive. So anything that we can do to maximize the value that we can generate for our customers, or to be as efficient as possible, was something that is very prized. And that's where the data comes in, right? So you can see a picture here. I'll move my mouse around of this mainframe room. So this is taking us into the into the 70s, where really things started to boom with computing. The computers were becoming more and more commonplace is not the right word. They were becoming more and more as differentiators for businesses, and Schneider was one of the pioneers in setting up a fairly large computing infrastructure. So we started to develop the horsepower in the 70s, and through the 80s, Schneider was one of the pioneers in EDI and electronic data interchange. This is how we receive our orders. So again, you can see it's streamlining the way that we connect with our customers. It makes it easier for them to do business, and it makes it easier for us to respond and service their requirements. EDI also means that we have a lot of dependence on modern computing technologies and modern communication technologies. Again, a major source of data that feeds the powerful computing infrastructure that we had been developing. Schneider was also the pioneer in in-cab computing. So the Qualcomm computing units that we see in cabs, onboard computers, Schneider was the first company to install them in cabs. And not only did they make it easier for our drivers to stay connected to our customers and to the enterprise, it also again generated a lot of valuable data that could then be used to generate insights on how to service our customers better and how to run our operations more efficiently. Some of the other highlights you'll see here are their rating and customer purchase order management technology. So again, applying computational technology, applying computers, and applying the horsepower to again make it easier for the customers to do business with us and to diversify the services that we could offer to the customers. Trailer tracking is another major milestone. So just to know where the trailers are, how far they are from their destinations, is there any problem going on with the driver or with the trailer while they're on the road? Just information like that allowed us to receive the data that could allow us to respond to customers. Okay, this is how far we are from you. This is what to expect when you can expect the delivery and or the pickup and so on. So not only better communication, but again a major source of data. Then came a fairly large, actually a very large modernization of the ERP and transportation management system, along with many other software components that were used to do business. So this is the Quest, right? Quest is a major initiative that Schneider undertook in the late 2000s, and that continued for over a number of years, where we did a thorough modernization of our infrastructure, and a lot of new practices and were created not only around data management, governance, warehousing, policies, and so on, but also provided us a new suite of tools that we could apply against this loads of data that we were generating to more quickly offer insights and diversify the insights, and also diversify what we could do with this data. All that modernization led us to another milestone, which we continue to develop and evolve, which is dynamic data-driven decision making. So this is really a big application of decision sciences and optimization technologies to automate aspects of decisions that are made in the organization. And all of that you can see, right, how everything is connecting, right? From modernizing the computing infrastructure, the tons and tons of data that is generated by newer services, modernization of our infrastructure, leading to I'll call it automated decision making, but really it's creating the frameworks and platforms that can help us make better decisions across the organization. And throughout this, we have also diversified the type of data. So we've increased the variety of data that we work with. For the longest time, we used our relational databases, right? And various providers of that. But now we are increasingly using NoSQL based data sources. Again, that is the next frontier in big data that also allows us to apply newer development technologies and really expands the creativity of our folks. And we are constantly looking to grow in this area. So I said a lot of words. I showed you a very dense slide.
I
Curious
thought of a
what question.
question. Um, I have some familiarity with the local history. Does this history encompass Schneider Logistics as well, and some of their bringing, data into the mix?
Yeah, so everything that I talked about, everything that I showed you have touched various business units of Schneider. So I'm not calling out one business unit or the other specifically, but yes, Schneider Logistics has been one of the contributors and beneficiaries of everything that I've talked about. Does that answer the question?
Yeah, thank you.
Okay.
Will you be getting into some bit about your teams inside the company? There's a question that could be asked, but I wanted to tie it to if you've got material on kind of how your teams are structured.
Sure. I will talk about teams in the context of how we do these projects. I will not be going into specific details of how each team is constituted and too many details, but I will give
All
you
right.
an understanding of
We'll
what
see
it
if the question applies after that. Then thank you.
is. All right. Anything else? Okay, so let's move on. So the last thing I want to say here is that across the industry, Schneider has been recognized as an analytics leader. All of the work that we've done over the years, I've highlighted just a small number of prominent recognitions that we've received. Schneider is very active in INFORMS, or the Institute for Operations Research and Management Sciences. And Schneider has won a number of INFORMS awards, as well as been the finalist in another number of those. So I've listed a few of them here. More recently, in 2020, we were recognized by FreightWaves as a top 25 technology in freight, the Freight Tech 25 award that I show here. And we also received the Big Innovation Award in 2020. Okay, so that's all I want to say in terms of introduction to the company. So let's talk about data science, data analytics, and AI. And this is where I'm looking for some participation from folks. So if you had a buck for every time you heard these terms used in your professional life or even outside professional life, let's do some math. In 1 year, you would have how much? Who wants to go?
Feel free to type it into the chat. We'll see some stuff there, and
Sure.
see if people fly along with what they think.
I'd go with $3,650. So about 10 times a day I hear it.
Wow. And this is all professional life, or is it everywhere?
Mostly professional. I'd like to say my wife talks about AI and stuff, but that's more to get me to get things done faster but not so much.
That's the highest number we've heard. We got 2,000 out of the chat. 10,000.
10,000, wow. Is there a particular industry that you hear 10,000 times?
Pradeep, go ahead.
Sorry, I was on mute. So, I mean, yeah, it's a common topic that's talked about at any like think about any meetings that you attend or the seminars you attend, webinars you attend. It's been there ever. So it's a common, I think, terms that is used across wherever you go or TV. That's also, I mean, everything is around data science, analytics, and AI.
Mm-hmm. Yep.
And
So,
if you add IoT and ML to the discussion, then you're going to have 5 times
Correct.
more.
Then RPA is another one. So
yeah. So we hear this a lot, right?
yeah.
But do we know how many of us even know what these terms even mean, right? We use it so many times in our, now I would say in our parlance, and we use these interchangeably. But are these really interchangeable? Any takers?
I'd say no, they have a particular meaning. And a lot of no's coming into the chat too. So
Yeah, AI is about making, it's all about that decision making and replacing human functions with, intelligence. So where data analytics and data science is really that study of the data, that I'm less able to give definitions there, but it's not AI in my mind.
Mhm.
Yeah.
Yeah, you're right. That is the purpose of AI. Data science, I would say, is one of the enablers of AI, especially given the recent progress we have made in what we can do with the data. So another question, right? How many of you are applying these in your organizations?
So obviously, I told you, right, we have a data office at um, Thriven Financial.
Mm-hmm.
So yeah, we hear about data lakes, data science, data analytics, and AI. So obviously, we are also trying to leverage a lot of this data into kind of the buying behavior of our members, or even project out some numbers, like it's all out there.
Okay.
In my organization, not very much.
We use Microsoft products in the cloud, so we're using AI on a daily basis, right?
Right.
Okay, isn't done. So sorry.
We're seeing that in the food service industry, IPAP is getting into business intelligence and leveraging dashboards versus Excel and distribution of reports. So some take up.
So are you getting any value from these? So we heard different industries are using these technologies in different ways. Are you getting any value? And how do you know?
I'd say that's hard to answer. Type some thoughts into the chat if you think you have some idea.
Yeah, this is Jill from IPAP. We actually released a bunch of dashboards and we can't get people to actually use them. They're actually people outside of our company, the companies that we support, and they don't even go look at them. So I don't know what they're using to make decisions on their sales and products that they're selling and buying.
Yeah.
I mean, definitely.
I was just going to say, I think food service is a little bit behind than most other industries.
Well, something that related to food, but on the retail side, we have developed AI solutions to know in Burger King what type of hamburger needs to be ready at specific day or time. So we do have dashboards that shows, how fast we can get the customers out.
Okay, that is a very interesting application.
Yeah, Schreiber, I think you guys are pretty far ahead.
I mean, I think there is a lot of value, right? That's why if you hear everywhere, right? Every company, I mean, across different domains, they are using it because, like, if you go to a retail store, also if you are closer to a retail store and if you have an app, you get a kind of a pop-up saying that okay, there is a deal that's going on, right? I mean, you never thought about like we were hunting for coupons and here and there. Now it's like at the tip of your finger, right? So it's all, I think it's made possible because of all this.
For us, measuring value has been hard. We try and find metrics that are a proxy to what might be real dollars by saying, well, if the people are using the systems and the projects that they've asked us to do have a stated time savings or some value, we measure it after. And our metrics are showing slow, steady kind of adoption increases, and that's how we measure value.
Got it. Yeah, so I wanted to show you this, and then I'll come to my point. In many of the industries, this group is an exception because at least we have a good understanding of what these different terminologies are about. But in many industries and in many people, this is still the reality. I was at Informs last year, and I attend as part of the roundtable. And the topic that we spent 2 days talking about was how do we get value, and are we getting any value from these kinds of technologies, and just sharing with each other, well, what have we learned? And when I showed this, I found this outside one of the cubicles, and when I showed this resonated a lot, right? For us, it may be clear, but is it clear across the companies what these things are and what does it take to get any value out of them? And it is well recognized in the industry that operationalizing and sustaining data science is challenging, right? I did some research and found that Forbes has Forbes awards CIO innovation awards every year. And out of the 8 or 9 that I researched, there was only one company that was recognized for the benefits that it has derived from a data science and analytics platform. So clearly everybody is talking the talk, but we are not seeing enough benefit from this yet. This slide here, this picture here is actually a picture from Gartner. Gartner does this research almost every year or maybe every other year around what is the value that people are getting from the new technologies, and for data science and analytics projects, they found that it is really hard in the industry to get value. And they listed some of the causes here, but you can see the number one cause is how difficult it is to deploy these things into the business processes and applications. We can get the data, we can write some algorithm to generate some insights, but actually then applying that into a business process so that it can be used in a repeatable fashion is currently the biggest challenge in the industry. Another challenge that is mentioned here are DevOps skills, right? So as our data grows, expands, it diversifies, and when we look at, well, how do we implement this data science into our operations? This is where DevOps really comes in a big way. And again, this is one of those buzzwords that is only recently started to get more understanding in people. So, and then there are a whole bunch of other causes. By no means is this list complete. Every company has their own unique challenges. But you can see that we are not alone. And what we found in the experience in developing and deploying these data science and analytics technologies to derive value is that there are four components that lead to value generation from data science. One is to make sure that we have a data-driven design, right? We got to understand what is in the data and what is the problem we are trying to solve, and we design the solution for that particular business problem, and leveraging the type of data that we have. Having the correct roles in the organization to work on these projects is very important. So these are both project roles, but also skills that we need to have. Third thing we learned is we need a sound development practice. What does that mean, right? What that means is that we need to have good methods and repeatable methods in place to approach these projects. If every project is its own discovery, if every project is its own, well, we have to create our method for doing the project, it doesn't work. And then finally, we need sound and well-established processes. And then we can get value from data science. So in the rest of the talk, I want to go into a little bit more detail around each one of these topics. But let me open up to the group. Does any of what I talked about resonate with you?
I'm surprised the data quality issue is entire.
Good point.
Yeah, I think that's probably one of the challenges with, I mean, at least I've heard that that's a common topic, data quality of data. How you bring it to a common place, like,
Definitely similar challenges. I would say that ranking that you have in the graph is very much like what we experience at our company.
Mm-hmm. Okay, so let me show you one more. This again I found while walking around the cubicles, and a lot of projects actually start off like this, and then dawns the realization. All right, so in Schneider over the years, we have developed an analytics platform, right? This allows us to develop, implement, and scale data science applications. And there are four pillars on which this is based, right? Everything starts with the data science, right? So we realize there's a business problem that can be solved by data science techniques. And these techniques are typically three types, right? There's predictive analytics, there's prescriptive, and there's descriptive. So at a high level, we need to recognize that this is a business problem that can benefit from these methodologies. Okay, once we understand that, in order for us to implement this and scale it, we need to have a clearly defined architecture. That is the backbone of any data science solution that we develop. And this architecture needs to be made of reusable components, and it needs to be repeatable. So like I was saying before, we shouldn't have to figure out what the architecture should be for every single project. Yeah, there will be some specific components, but not the overall backbone. Third thing is feedback services, right? So it's all well and good to apply a data science method one time, but as you know, business changes, the needs of our customers change, the economic climate changes, and so on and so forth. So collecting the feedback on how this technology is performing, how is it being used by by the business, by the customers is extremely important, because once we have this data, we can figure out where the shortcomings are and we can continuously improve what we implement. A lot of times we implement data science applications. Within a year, nobody is using it, or within even 6 months, nobody is using it. And why? Well, it doesn't represent what's going on. I don't trust the results, or people change, things happen, right? So this is where feedback is very, very important. And not only to collect it, but to use it to have a program to continuously improve these technologies. And then finally, modular design, right? So why is modular design important? These applications can get very complex very quickly. So a little bit back, we were talking about data quality and the variety of data and so on. Now think about if you are applying this in a business process to improve or to modify various aspects of business operations, how complex it can get. The needs of the users are so diverse. And in order for us to cleanly maintain these technologies, to make improvements, we want to be able to do it fast. We want to be able to do it in a very surgical manner. And this is where modular design and loosely coupled components come in. So I'll go into these details in the next slide, and I'll walk you through at a high level uh, how is this platform constructed and what have we learned along the way. So again, a very, very dense slide. And I'll walk you through each component here. The three keywords I want to leave with you are A, compartmentalized, B, containerized, and C, stateless. And so then let's go through this and we'll revisit these terminologies, right? So everything starts with the data, right? We have a fairly extensive data lake, which comprises both relational and non-relational data. It comprises a lot of data generated by our applications and operational systems, as well as a lot of data we collect from outside. This data grows not only in quantity, but also in variety. Because now we are able to effectively use a lot of the publicly available data, or even data that can be brought from outside, right? And mash it up with the data that our systems are generating. But you can see, right, if you have this variety of data, it can get very complicated to A, understand, well, what do I really have, and B, how do I get to it, and how do I use it? So we've developed methodologies to abstract this data. So again, these are services that we create that allow our users to access this data in a more simple manner, and not only to read this data, but also to write to the data lake. So from a developer's perspective, it is much more straightforward to access and use this data. So on top of all these abstraction services comes the actual models, right? So this is where the science and the art come in. So we understand what the business problem is. This is where we actually create the fun models, right? How am I going to use the data to solve the business problem that I understand? Now, every project typically requires a different model. I mean, this is just a given. What is common here is the modeling platforms that we use for the predictive, prescriptive, or the statistical or descriptive models. So there is some commonality in the modeling platforms. There is some commonality also in the solution algorithms, not the data science algorithm, but the solution algorithms, right? Once we have created the algorithm to solve the problem. And then finally, I've drawn boxes around these, and these boxes are for a reason. This is an abstraction. So each model is its own abstract piece that is running in a stateless fashion. And these models now, over the years, we have applied in all aspects of our operations, ranging from customer interactions all the way to revenue management, to planning, and to execution. What these kinds of abstractions and stateless architecture and containerizing these models allows us to do also is where it makes sense to do self-tuning and automated configuration of these models. Because again, we are not creating everything altogether, but we are able to plug and play into what we have created. If we need to do simulation to understand what would be the business impact of making some change, and we want to run it through our models and inform us, we can plug these models into simulators, and we can apply these without having to do a whole major project every time. Everything is enabled by services and APIs that are created for all of these different components. And a lot of times these models plug into some application that we are creating or into an application that we own. So again, having this kind of compartmentalized, containerized, and stateless architecture allows us to plug into these different kinds of applications. On the left-hand side, I show you feedback, right? So this is again, feedback is its own separate piece, which is a reusable component and repeatable component that we plug into each one of these different types of models, and we collect a variety of feedback, right? It could be usage, how is this technology being used, who is using it, compliance, how well are the recommendations being followed, how well are these models that we have created, how are they actually running, how are they performing, and then what sort of impact are we having on the business. And then, so this is all the data that's collected, but then this data is then used to make improvements on an ongoing basis in an automated fashion where it makes sense, but for the most part, it's through a continuous improvement program. So again, I've walked you through a lot of content here.
I have a question that might apply. You let me know if it's here or later, but it relates to the situations where you have vendor versus build your own aspects to how you build out this kind of architecture. So the question is, how would you handle situations where purchased packages have their own embedded analytics that have been developed with their different approaches, and how important is it the decision making, and maybe where does it fit in with how this architecture thinks in terms of vendor provided versus build your own? Is this a completely build your own, or is there elements that you fold in other packages from vendors, and how do you deal with how they have differences?
Sure. Yes, this question does apply. And this connection I'm showing you here, a lot of times the science needs to talk to some application, right? So that is one area where a vendor provided application or vendor provided technology comes in. That, okay, the brains behind that could be self-created, but how it gets used is through a vendor delivered application. That's one of the instances. And so in that case, we'll be talking to the API that comes with those applications. Another case could be that there is some algorithm that is commercially available that we want to purchase, or that we want to have a vendor develop for us. Again, we in this case, depending on what it is, if it's an algorithm that we are wanting to apply, they typically come with their APIs that allow us to connect to them without having to see the inner workings of, or without having to worry about the inner workings of those. So that is another way that we have used it. But Schneider in general is a build your own shop. We do a lot of our own builds, and we do a lot of our own builds because it allows us to customize the solution for the specific business problem that we are trying to solve. So does that answer the question, or am I
Tina,
missing the?
I think that was pretty good. Tina, do you agree? That answers your question? Yep, good. Thank you.
Okay.
Any other questions? Feel free to type them in or speak up now. Thanks.
Okay, so there was a question earlier about teams and what does it take to do a project like this?
Yeah, does that apply? Come after this. All right, I'll ask after.
So it does take a village, right? So this is another learning that we have. And I'm showing you here at a very high level the different teams or the different skill sets that it takes to do a project successfully, right? So we need an engaged and involved customer. That I cannot say enough about that. If a customer is not engaged, if a customer is not involved, A, there will be a lack of understanding of the business problem. B, whatever gets developed, we would never know timely if that is indeed representing how the business performs, how the business unit functions.
And you mean internal customer?
Internal customer.
Yeah.
But I would say customer in general. If this kind of a project is done for an external customer, we would need an engaged customer there as well. Secondly, engineering. So this is where all the algorithm creation, the science creation comes in. So every single one of these projects has a substantial presence of these engineering skills. A third skill I wanted to list here is advanced analytics. And by this, I mean computer science skills, the building skills, right? Because what I showed you in the previous slide was a fairly complex architecture with a lot of modularity and reusable pieces that needs to function at scale, at the speed of the business, at the scale of the business. It needs to consume a lot of data fast. So this is where we really need a solid and a very high quality build. And that's the type of skill set I'm talking about here when I'm saying advanced analytics. And this is all a partnership between the teams. These projects consume a lot of data. They need a lot of data engineering. They generate insights as these projects develop. And this is where the business intelligence skill set comes in. So this is where typically the data is managed, owned, governed, curated. Everything is done with this skill set. So it's a very key component to enabling access to the data and to developing an understanding of what is really going on in the data. A lot of times these projects will be part of a bigger application development project or will be talking to an existing application. And so we need the application development skill set. So this is really the developers who have created or who are creating these applications that can partner with us in the communications between the applications and these data science architecture. And then finally, support. Right. So I talked about feedback. I talked about needing to continuously improve it. This is another skill set or another competency that we need in these projects, where we have a formal program of working with the feedback and the performance of the systems that we developed and make improvements in these models or in the architectural components on an ongoing basis. So I'll pause here.
Yep, the question that was previously thought of as answered by this picture, other questions that have occurred. I would appreciate if you could distinguish your business intelligence area from the others by more about what makes it different than app dev or advanced analytics.
So in this case, we are very skills focused, right? So in the case of business intelligence, the focus of this team is on the data and in generating the insights from the data, right? So app dev is a separate skill set. It's a separate team whose focus is more on building these applications. So they are the programmers, I would say, at a very high level. Does that answer the question, or do you want to go into more detail?
Nope, that helps me. Thank you.
Okay.
Any other questions? Type them in or speak up. All right.
Okay. So again, I'd like to very quickly go through how does a project like this even work, right? So here I'm trying to show you the phases in which we build, right? So we start with the customer. There is a discovery process to make sure that we understand the business problem and that we can indeed solve it with data science, or that we can indeed help the customer in this way. This is also where we create and conceive of the algorithms. And then we build. We build the models, we build the systems. So there is a sizable data engineering enablement for all of these steps. Once everything is built, we start generating insights, right? Because something is running now, something is using the data, something is generating valuable information from which we can not only tune the system, but also generate early value for our customers. And then operationalizing enterprise analytics, which has typically been a traditional role of BI, and then monitoring and tuning, which is where the feedback comes into a big way, and the support and continuous improvement of these applications. This is not how we do projects, and this is not how to do projects. And yet we see a lot of this happening in the industry. Oops.
We had a question that might apply somewhere around here. In the data science AI side, do you utilize a lot of Python or R?
We do utilize them both.
Both. Good. Thank you.
Okay, there was a comment earlier about data quality. Yes, that is very important. And this is a role which is often painfully neglected or underestimated. When I talked about data engineering, this is one of the big things that is done as part of that. But even before that, maintaining good quality data is absolutely essential. Analytics is also an important enabler of Schneider logistics. So previous to my current role, I used to work in logistics area, and we used to use a lot of this is a picture of Tableau, but we used to use a lot of BI tools in conjunction with algorithms sitting behind them to generate insights for our customers, right? So when we work with the customer data, this is what we can offer to them and show them how can we support them. All right, so I talked a lot about what we've been doing, some learnings, but I think we can all agree that data science and getting value from data science is hard. This picture at a high level shows you that there are often two competing priorities that we encounter, right? On the one hand, it's a new business problem. There is new science that needs to be created, and there is a temptation that let's create something new and let's keep making it perfect. Let's keep improving it, almost running it as a science project. And on the other hand, there is a bias. There's a strong bias to action, right? We got to get value. We got to get value now. But what that can do is it can really dilute the quality of the solution that we could develop for our customers. So there's this constant tug of war between these two areas. And by having a good process, by having the right roles, and by having an engaged customer, everything I talked about, we can get through this quote unquote conflict of ideologies. We've learned a few lessons, right? So I talked enough about partnering with the customer from the beginning and having an engaged customer. A change management is very, very important. So even though there is a business problem and our business sponsors realize that they need help from data science and that they can really improve, it's still going to be a big change for them. It's going to be a big change for them to take in these technologies. It will be a change in the functions of the folks that work in their teams, and they will internally encounter many hurdles, and people don't want to change, right? So I mean, we have to listen to our customers. We have to talk in their language, and we have to plan for change management. Often projects are planned without thinking about what will it take to actually get buy-in from the customers so that they can agree to use it. So we have to plan for it. Making them comfortable, right? Change is hard, change is uncomfortable, and there'll be a lot of pockets of resistance. So slowly by slowly, with an engaged set of customers, we need to leverage we need to leverage our supporters in the customers' organizations and and address their concerns, make them comfortable with the technology. This can take a lot of time and working side by side with the customers to get them there, but it is very, very important. And the last thing is passive aggressiveness. So a lot of times what will happen is we'll see nodding heads, we'll see smiling faces, but internally they are not they are not accepting the solution. So how do we detect it and how do we address it so we can mitigate it and we can address their concerns, right? Passive aggressiveness often comes from, okay, there is a concern and people feel that they're not being listened to. So how can we make sure that they are heard? And even if we see a smiling face, well, follow up and talk to them and see, is there something that is left unsaid? Agile development, agile is is a buzzword, but it is also a very well accepted development methodology in many companies. I'm sure a number of your companies are also doing agile, and it is the way to go. When we look at engineering and data science, a lot of the principles that underlie how these data science projects are done is agile in philosophy. But now I'm talking about building this architecture, building it into applications. Agile development is absolutely the way to go. It helps us to hit intermediate milestones, deliver value, and make sure that our customers are accepting of what we are doing and they can clearly connect with value to their business. However, businesses don't operate in an agile fashion. They don't think agile. So there is that conflict that happens, that even though the development is agile, our customers are not, our customers don't work in an agile way. So overcoming that barrier is very important. And then finally, begin with the end in mind, right? This is a very, very commonly heard principle. We got to have the end state in mind as to what exactly are we going to develop for the customer. Don't shortchange the discovery process. The discovery is important not only for algorithm design, but it is also, this is where the conversations, critical conversations with the customers happen around how is their business problem going to be solved and how are they going to get value. This is where buy-in starts. And align across the business problem before defining the metrics. Questions?
No questions I've seen yet, but yeah, I got to tell you, there's been a lot of love for this slide in the chat. So this is a great one. A lot of good ideas here. Any questions? Feel free to type them. Get them in there before he moves on to the next slide.
Okay, so just a little bit more wordiness here. I'll go through these next two slides very quickly. So data, do we have it? Can we get it? And is it good quality, right? Everything that I've talked about so far is summarized here. And if we don't have data that directly represents what we are looking for, are there alternatives available? Understanding what needs to change in the business process and having the change management, which I talked about. And then financial ROI analysis, right? This is basics. Before we go into a project, we got to understand and we got to align with the customer. What is the value? How will we measure it? If we don't understand a clear path to value, and if we don't have a clear way of measuring it, it is not worth doing the project. But often this aspect can get neglected. And it behooves us as analytics professionals to drive this discussion if it is not happening already. And then barriers are also in the form of data. We talked about that. We talked about buy-in and financial. So I'll pause again. Are there any questions coming up?
There's a good one that talks about data privacy challenges. Maybe that's a barrier to success.
It can be. Again, this is why it is important to understand what data do we have? Can we use it? And how are we going to use it? This is where the discovery, design, and the buy-in process is so critical. And in some cases, it may not be feasible to use it depending on what the constraints are around that data. And maybe there is a surrogate, maybe there isn't.
Do you have any particular data privacy challenges that you can share or give insight on?
I wouldn't be able to go into specifics, but there are basic stuff, right? So information about customers, for example. There are certain types of information we just cannot reveal even within the company, right? So in that case, we end up looking for, are there market surrogates for this? That publicly available data, for example. Or is that piece of information really necessary? Or it can also be a challenge in who gets to access. We may not use that particular field of data, but it sits in tables that are sensitive. So who should have access to that data? And can we streamline a path to access that data? Or do we need to abstract it differently? So we run into these challenges on an ongoing basis. Absolutely.
Yep, good. Anything else people are typing in? Feel free to type now or unmute and speak up. Oh, here we got one. Things like GDPR come into play with data privacy. Good point, Kevin.
Things like GDPR would come into play. I have not been close enough to that to be able to speak in an educated way about that.
I would say from my perspective at my company, we occasionally bump into GDPR, but often it ends up being something I inform up the leadership executive tree, and we end up moving forward to try to get to solutions with the data despite GDPR. It doesn't slow us down. Any other questions or thoughts being put in? Pradeep was thinking that you don't have as much personally identifiable information type issues that you might be dealing with.
Enough, yeah. I mean, as compared to a financial firm, absolutely, it's different.
Any other thoughts? Feel free to unmute. All right.
All right. So last few slides, I'll give you a quick example of one of these kinds of projects that we did for our bulk division. And these were slides that have been shown in different venues, Informs being one of them. So really the challenge, just the size of the business, right? So Schneider Bulk, you would have seen tankers that look like this on the road. We service many customers, a wide variety of commodities and a wide variety of equipment that ends up getting used. And these equipment need to be washed before and after, cleaned before and after deliveries are made to the customers. And the specific problem we were trying to solve was, well, how do we efficiently run this network? Because there are so many different steps and so many different entities, drivers, trucks, variety of products, and so on. And it's a very complex way of running the operation. So this is an optimization method that greatly benefited from the architecture and the principles and the team composition that I described to you previously, and generated measurable business value for the business. Right? It was efficiency, it was productivity for the people, and it improved the experience of the customers just because we are better able to run these operations. And so this was the last slide I had around what we are doing with the architecture and what we have learned. Just want to leave you with this very last slide that there's an explosive change happening in our industry, the transportation industry, but across industries, right? And we have increasingly not only larger and larger quantities and varieties of data being generated, it's becoming more and more complex. It's showing up in so many different aspects of our operations. I heard IoT a little bit earlier. Absolutely, we have a lot of data jets generated by equipment. That's all IoT data, and just using it, managing it, and extracting value, it'll just keep getting bigger and bigger of a challenge, as well as bigger and bigger of a pie that we can all benefit ourselves from. That's my last slide, folks.
All right, nice. We had a couple of questions that might take us back a bit architecturally or wise. You had a bit where you were showing about your data lakes. The question is around data lakes and data warehouses and data marts. Are you using kind of all three, or how would you say you focus? Because I remember seeing data lakes, but not much mention of data warehouses and data marts.
Yeah, so I'm using data lake as in a fairly loose fashion. I'm looking at that as a reservoir of data. Yes, we do data warehousing, and yes, we used to use data marts a lot, but yeah, for me, when I use data lake, it's where all the data comes in various forms, whether it is through a warehouse, whether it is raw data.
Yep. And you're building canonical data models with data catalogs? Do you think that that's part of your process?
We do some data modeling, and we do some data cataloging. When you talk about data catalogs as commercial software, cataloging software, that is something that we don't utilize in a big way, but we do model our data. We do record what we have done with the data, what the fields mean, and so on.
Sure, nice. And another one was a little bit more on the technology stacks and tool sets. Do you have anything you can share on particular ones? Or is everything kind of homegrown?
Yeah, I mean, if you could be more specific, I would appreciate that. At a high level,
Sure.
we use a lot of Python and R, and we use them to build the data science models, as well as to build the architectural components. We use Java as a base programming language as well. We use commercially available algorithms, but again, with these software platforms or software signatures in mind, we
Sure.
do build a lot. We do really build a lot. Uh, and like I was saying before, we build because it allows us to be fast and it allows us to be custom.
Sure. And Hadoop, like where's the data platform?
So we are a big Oracle shop. However, for non-relational, we've been using Hadoop. We've been using the cloud. We've been using a variety of sources.
Good. And but shifting gears, can you talk about how you have engaged the business when they didn't know what they need or aren't familiar with the data, insight, and metrics? Probably the heart of that one slide you had where we were getting to know the customer.
Yeah, so there's not one way, right? We have to keep talking to our customer, and that's just the basics, right? So many times discoveries happen in conversations with our customers. A number of times there are particular business initiatives that our business units want to improve themselves in, and that leads to some solutioning. Uh, and in some cases, we have done business previously with the customers. We've generated insights, and it takes our people to look at those insights and ask the questions. Sometimes it comes from our business customers, sometimes it comes from our teams. But there's not one silver bullet. We just have to keep talking to the customer. That is very important. And we have to do our best to help our customers, whatever their needs are, just to have that connection.
Keep that conversation going. Have you found anything in particular helps keep the conversation going? In my work, there tends to be a desire to get to some kind of results, and the conversation gets shorter and shorter unless we can show some kind of rapid prototype. So in my case, there's a lot of, okay, at least we can kind of show something to keep the conversation going, which means that we build something with very little data and very little value, but we keep the conversation going. Is there anything you have to say about that?
That's definitely a part of it, Paul. When I say we need to help our customers, the needs could be anything, right? Sometimes it could be a very small thing that they could benefit from. So do our best to turn it around and engage them, but also be looking out for what is leading to this question that the customer is asking. Why are they asking for this? So that is one of the ways, right? The other one is absolutely prototype, show what we learned, show where is the value as quickly as we can. So when I was showing that dense flow chart, right, generate the insights throughout as we build is very important. We are also in a place where many of our business units understand that to get the maximum value, sometimes these projects will become bigger. So they do have some patience now with but there is, over the years, this understanding has come in. So that does help us to a good extent.
Sure.
But I would say if a customer is looking for help, do our darndest to help them, because that's where we discover what is a big problem here.
Very good. Feel free to keep typing final questions into here. We're kind of at the Q&A. Anything's open. And if you want to unmute, as long as we don't have a lot of people, I imagine you can get your question in. Go ahead. All right. I'll give people another minute to type anything else they want to type in here.
Sure.
Reminding everybody that the presentation is being recorded and it will be available on the LinkedIn page for our meetup. And next month, everybody's putting on their calendar, hopefully, the Kimberly Clark's journey as well. Remember, that one's not recorded, so please come and join us, attend. This was a great session with some really good participation in the chat and questions from everybody asking. So with the online format, having people not be able to kind of network the way they will, hopefully there's some real good value in people attending and getting some things into the chat and seeing some names of people they know. It's great. And no questions have come in, so I think, go ahead. Go ahead.
No, I was saying thank you. Thank you very much, Nikhil
Awesome.
and Paul, for arranging this.
Sure thing. Thanks to Nicole for really running the show on this and organizing, getting us together. Thanks everybody for coming. We're wrapping this one up for tonight. I appreciate everybody's attendance. See you at the next one.
Yeah, see you.